So how about 3 was pretty similar to that. 4 was a little tricky. I'm going to skip that one for now too. And I'm going to do pattern 5 again. So I showed some of my work yesterday for that. I just want to review that again. So there's a couple of ways to look at this one. I had 2 in this one. What do we have in this one over here? 6 in this one here, and 12 in that one right there. So if I try, say, well, this one went up by 4, this one's going up by 6, it's not linear. So it's not going to be something like 5 times n plus 3 like the previous one. So the other thing I recommended for problems like this, was to just describe what you see. And that was one of the columns in the table. So if I describe what I see, what I saw yesterday is I see a bunch of rectangles made out of squares. And the first one is, I would say it has 2 rows by 1 column. And then the second one has 3 rows, 2 columns. And then the next one has 4 rows and 3 columns. And I'm hoping to connect that with the stage. So this is the first stage, that's the second stage, that's the third stage. So is there a connection between the stage and the way I'm describing the rectangles?
We're each going up one, so I guess the next one's going to be 5 by 4.
The next one should be 5 by 4. Okay. So 5 by 4. That's stage 4. 5 times 4, so there's going to be 20 in there. And just notice here, this is the 4th stage, right? And 4 turns out in the description. Does the stage always turn up in my description?
No.
No?
I think so.
Well, here's the first stage, right? It's 2 by 1. Here's the second stage, it's 3 by 2.
Oh, in this case, yes.
Yeah, so in this case.
I thought you meant in all cases.
No, not in all cases, just in this case right here. Yeah, so in this case, and again, sometimes it does, sometimes it doesn't. It just kind of depends on the pattern. But those are the kinds of things I look for. Is there a pattern to how it's jumping? Not as easy as the one before. What's the next jump here? You get from 12 to 20. Oops. Oh, my pen's not tracking right. Oh, this is sliding off the wall. Try the tape again.
8.
Reset. About that. Fun with technology. Okay. All right, so that's our jump here. That's better. Yeah, we're jumping by 8. So there is a pattern here, but it's harder to describe than to add 5, add 5, add 5. But at least I can kind of draw it out. But the cool thing here is that it turns out the stage number turns up in the description of the rectangle each time. And then the stage number is what we call our n. So let me just I'm going to have to switch to the other board. Let's see, new page. I'm going to switch to the other board. Backup magic board. This one worked today, good. So we've got the stage versus the number of squares. So we have stage 1, 2 squares, stage 2, 6 squares, stage 3, 12 squares. We just stage 4, we said that was 20. And then we were supposed to hop on down. What was next on our list to grab?
Stage 20.
Stage 20 we got to come up with. Okay. So again, this right here was a 2 by 1 rectangle. This one was a 3 by 2. This one was a 4 by 3. This one a 5 by 4. What's stage 20 going to be?
20 by 21.
20 by 21. So I'm going to write it in the same order. I'm going to do the big number first and the little number second. So 21 by 20, that's all right. And let's see, what's that going to be? 20 times 20 is 400, 420? You guys got that too? Cool. 420 is what we think is going to be in there. So later we say, hey, the stage could be any number. That's what N stands for, some number. Okay? And so far, what I've connected is that the way I'm writing it, the second number, the number of columns, is always there. So in the formula for N, any number, oops, wrong pen, I'm going to have an N times something. And then yesterday we were trying to figure out what number is always right after N. What do we do mathematically to get it?
Add.
We just add 1. It's always one bigger, one bigger, one bigger.
Oh.
So that should be N plus 1.
N plus 1 times.
Yeah, there's always one more row than the number of columns in each rectangle, is what that formula says right there. All right, there's always one more row than there is columns. So the way I was seeing it was this one right here is rows, and this one right here is columns. And that was the hard part right there, figuring out that N plus 1 was how the way we write that out. So I'm just going to double check that for some number. I haven't put it in here yet, but we can figure out what's happening for stage 5. Oops. And according to my formula, N is equal to 5, right? And my formula says take N plus 1 and multiply that by N. Well, 5 plus 1 is just 6. 6 times 5 will be 30, which fits our pattern for how to jump to the next one. Okay. All right, the bonus problem.
On number 4, I wasn't sure.
Number 4?
Yeah, I check which stage has 625 boxes.
Yeah, so there we have to come up with a formula.
I got the formula, I think.
Okay, what do you think your formula is?
N times N.
N times N, perfect, it is N times N. Okay, so here's the tricky part then.
But then this stage that has 625 boxes wouldn't be like a
So here's where I think you're at. So you have a formula that says, for number 4, that your formula is N times N. And you want to know what number N gives you 625 boxes. So there's a couple ways to do that. One way is you could just guess what number times itself equals 625. And you can just play around with some numbers. Is there another way I can write N times N?
2N.
Not 2N, that would be N plus N, almost. N squared, yeah. N squared, so this would be another way to think about it. So then we want to undo a square. Anybody know how to undo a square? What is it?
Square root.
Square root, yeah. So it turns out N will be whatever the square root of 625 is. So we could go ask our calculator, what's the square root of 625? On a good day, I think it's 25. Elena agrees. N is 25 here. Double check about my Google calculator. 25 times 25 is 625. Yeah.
I was at
So that it just takes some used to. We haven't played around with squares and square roots and these kinds of patterns, but we're going to be doing a little bit more algebra stuff in this part of the course, so we're kind of just re-warming up to that. All right, this thing's hurting. Okay. Fix my little magic board someday. All right, bonus pattern. Does anybody think they came up with a formula for the bonus pattern? Sort of?
I think it's got an N.
It's got an N plus 1 in it?
Yeah.
It does have an N plus 1 in it. The question is what to do with that N plus 1.
It's like every time the number goes up, the number of boxes goes up. So it's like what you're adding that.
All right, hang on, I got it right here. I'm going to get used to this. So let's see, we added 2 to get to this one, right?
Yeah.
And then we add
3.
3, and then we add 5, and then we're going to add what next to get to the one we don't have here? Oh, wait, what did I write wrong? That's not a 5.
You had 4.
Okay.
4, there we
Just
go.
like all of them.
And then we're going to add 5 probably, because we need 5 more to get a new triangle. So there's a pattern there, right? Because to get from here to here, we add 1. To get from here to here, we add 1. To get from here to here, we add 1. Now that's not too different from this pattern back here, because these guys are how far apart? They're 2 apart. Now on this one in our formula, we ended up with an n plus 1 times n. So I just want to look at that on our new screen for a minute. If we take n plus 1 times n, remember we talked about the distributive property last term? So we can take and multiply this n in here. So that would be n squared, right? Plus 1n or just n. So that would be another way to write this formula. So we have 2 ways we can use the formula. The distributed way or the factored way. They're both good. So here's my hypothesis. I'm thinking since this one had a jump that increased each time, and this one has a jump that increases each time pretty similarly, there's gonna be an n squared in there somewhere, or there's gonna be something like an n times an n plus 1. So was anyone able to fiddle with those ideas and come up with a formula so that if I say, okay, here's the first term, second term, third term, that I can say n equals 3, and then I can just plug in and come up with an answer. Not yet. Daisy, any luck?
No.
Okay, so I'm going to redraw this. So check this out. So I'm going to try to give some hints. So the first figure, I'm going to use circles because they're easier to draw. So there's my first figure. Here's my second figure drawn a little bit different. Here's my third figure drawn a little bit different. And my fourth figure. So I'm just, it's still a triangle. I'm just making it a right triangle instead of, oops, extra wrong place. Goes right there. You can see that's really the same shape. I just shifted stuff over a little bit. And here's the big thing. This kind of reminds me of this right here. It's like if I just, took off some of these things, like if I crossed out that group right there, there's a triangle. If I crossed out, let's see, this group right here, there's that triangle. Okay, so I'm going to come back. Oops, wrong button. What could I do to these to make them look like the figures in problem number, what was that, 5? What's that?
Put them together.
Just kind of put them together, but or double them. So what I'm thinking is if I like flip that triangle and throw it up there, that's now a rectangle. If I flip this triangle and throw it up here, it's now a rectangle. If I flip this triangle and throw it up here, it's now a rectangle. So don't we know a formula? Okay, I guess I'd have to put another one right here to get that to match. Don't we already have the formula for these guys right here?
Yeah.
What's the formula for the black and the reds together? Almost, not 2n, that was
It was n plus n times n.
n plus 1 times n. Yeah, that's if I take the black and the red together. Black plus red.
N minus 1.
No, not n minus 1,
N plus 2.
not n plus 2. No. What could I do to just get the black dots out of this formula?
Get rid of n.
What's that?
Or get rid of the, yeah, that n.
Get rid of that n? Almost, you're getting
That
closer.
end, it's the other end.
Get rid of that end?
Yeah.
That won't do it, because
One.
so how are these, the black related to the whole thing? So let's take this picture right here. So I have this right here versus this right here.
Half.
Ah, there you go, it's half. So if I just cut that sucker in half, let's see if that works. Okay, so what stage is this right here? 1, 2, 3, this is the 4th stage. Okay, so let's test it. 4 plus 1 would be 5, right? Times 4, cut it in half. What's 5 times 4? 20 divided by 2?
10.
Are there 10 dots in the 4th stage? We did it together. That was a wicked hard one. Yeah. So let's see, we're in Math 92. That's a problem I'd give to my Math 111 students. So, a little unfair. Just thought I'd push us a little bit. So that one was optional. If you want to choose to write some stuff down there, go for it. It's worth a little extra. If you don't feel like writing anything down for that one, I don't blame you. Yeah, so finding those kinds of patterns is tricky. You got to mess around in a lot of different ways, and you got to be willing to be wrong many times in a row before you finally right. Now, as exciting as that was, the next thing we're going to do is even more exciting. Does anybody need a copy of worksheet 432? Okay. Oh, I thought I printed them already. I put them in a different stack, apparently. All right, I will go grab those in just a minute. They must be sitting on my desk. So we're going to move on here to 3.2. And so just a little warm up to lesson 3.2. There's 2 big things in lesson 3.2. One is working with percents again. And the other big thing is we're working with formulas. So I just wanted to refresh on some formulas you're familiar with before we move on to some more complicated ones. Think about area for a minute. Anybody remember the formula for the area of a circle? We looked at that a little bit way back when we were building stuff last term. It's got the radius in there. What else has to be in there? Circle. Pi r squared. Yeah, there you go. Yeah, pi has got to be in there because it's a circle. And because we're looking at areas like square floor tiles, it turns out the radius squared is in there. So given a circle, if we know the radius, the distance from the center to the edge, if we multiply that radius by itself and then multiply by pi, that'll give us the area of a circle. Okay. So just for fun, consider a square that's 2 by 2, and then I stick a circle inside of that.
No.
You hate these.
Yes, one where you have 2 shapes and like.
Oh, we're not going to mess with the 2 shapes. This is just for reference. Don't worry about it. It's not that bad.
Okay.
What's the radius of this circle if it sits in make believe that's a circle? What's the radius of the circle if it lives inside of a 2 by 2 square? Radius is 1. Yeah. So as far as my area goes, pi is about what? 3.14. Now that's the most common version of pi, but did you guys know that it was, I don't know, not too long ago, about 30 years ago or so, I think it was Minnesota tried to pass a law. 3.14 was too complicated. They tried to make pi 3 because that was just easier to work with. Right? And you're like, wow, that's nuts. But I mean, if I had to do a calculation in my head, what am I more likely to multiply by, 3 or 3.14? 3. That's close enough. So I'm just going to say pi is about 3. So approximately 3 times a radius of 1 squared. Let's see, that would be what? 3. Now, if this is 2 by 2, what's the area of the red square? It's 4. And since the circle lives inside, it's got to be smaller than 4, and it's smaller than 4. A better answer would be to say pi is about 3.14. So we could say the circle's actually closer to an area of 3.14, whatever the units are, square feet maybe, versus the square here, which is 4 square feet. So just a little warm up in using formulas. What's that?
Pi is actually like 8 or 9 decimals or something weird thing, isn't it?
And pi is nuts. Okay, so I'm glad you brought that up. It's just a little side note. 3.14159, yeah. I had a friend who had like 300 digits memorized. I saw a video of a kid on YouTube who recited 10,000 digits. He learned pi as a song, so each digit had its own note, and he would sing it to get it. And he just had that much of it memorized, right? There's a pi club you guys can get in internationally. You got to memorize at least 100 digits to get in the pi club. If anyone wants to go for it. I think you have to get a tattoo also, I'm not sure. So here, there's a Pi Day coming up. Oh, that's this quarter. We get to celebrate Pi Day with pizza, which is a pie, as long as it's round, and other pie. Here they have 1,000,000 digits of it. So it turns out pi has an uncountable number of digits. They go on forever. And there's kind of a pattern, but there's kind of not. Without calculating it, I can't tell you what the next digit's going to be, which is kind of weird. So yeah, it's got a ton of digits. It's a weird number. So more about pi on Pi Day, which is March 14th. Yeah, there we go. One of my favorite days of the year. Okay, let's see. And I put this link in the wrong spot. I'm gonna have to fix that. All right, so a little bit more warm up here. Another formula related to pies and circles. And this is relevant to today. What is this figure right here? Probably a cylinder. Okay, let's see if I can spell cylinder today. Pretty sure that's how you spell it. Everybody agree? Looks right. Okay. I looked that up before class just to be sure. Not very good at spelling. So that's a cylinder. A cylinder is also a can, right? And a can has two different things. Geometrically, it has an area, right? So that would be like the label of the can and the top and the bottom. And then it has a volume. And the thing we're going to be looking at today is percent alcohol content. So if people have an alcoholic beverage, it's in their system, it affects their ability to do things. So we're going to talk about that measurement. But knowing about areas and volumes is kind of important. The cool thing about a can is, well, don't we know the area of the top of the can? Yeah, it's just a circle. Area. There's pi times the radius squared, and there happens to be a top and the bottom, so there's two of those. What's that?
Yeah, times it by 2.
Yeah, multiply it by 2. And then I have to add on the outside of the can. Well, that's just the label, right? You ever peel a label off a can before you recycle it? What happens if I take that label and spread it out and lay it on the table? What shape is it now? It's a rectangle, yeah. So the label is really a rectangle. And the rectangle has a length and a, let's call it a height here instead of a width. What did that length used to be on my can? What's that? Well, just the length of the rectangle, just this part right here. So that part right there, let's highlight that in a different color. That used to be what on my can? What do we call that on the circle? Circumference. What was that?
Circumference.
The circumference, right. And how, anybody remember the formula for the circumference? It does have the diameter in it, yeah. That's one way to look at it. You can also talk about it with the radius. So there's two different formulas for that circumference. Anybody want to take a stab at one of them? Michael, you got this. It's okay to be wrong. Give it a shot.
Is a radius? No, I don't remember. Radius squared times.
Radius squared would be area. So this is just circumference. So it doesn't square anything.
Diameter times something.
what something is always in circle formulas.
Pi.
Yeah, so one version is pi times the diameter. The other version has pi in it, it has a radius in it, but I need one other number.
Times 2.
Times 2,
That's
yeah.
what I was saying.
Yeah, because the diameter is twice the radius. So I'm going to use that version since I mentioned the radius here. So what's the area of a rectangle? Isn't it just length times width? Yeah, so the length of that is just 2 pi times the radius, because that's the circumference. And that height here is just the height of the can. So that right there is the volume of the area formula for a cylinder. 2 circles and that rectangle, part of the rectangle is their circumference. Kind of cool. Other cool thing is a can is a lot like a box. And if I wanted to find the volume of the box, wouldn't I just take the length times the width times the height? Remember we did that last term? And the cool thing about the length times the width here, the length times the width, isn't that just the area of the bottom? So the same thing works for the can. If I know the area of the bottom and I multiply by the height, I'll get the volume, just like in the box. So what's the area of the bottom of the can? That circle right there.
2 pi radius squared.
Well, that would be the top and the bottom. So just the bottom would be pi r squared. And then I just need to multiply by the height to turn it into volume. So that's just the volume formula there. All right, so let's do a calculation for the volume of a can, which is going to be pi r squared times the height. Now, since we're going to be talking about blood alcohol level today, let's guess at the dimensions of a beer can. This beer is a pretty common drink here in America. So think about a beer can. How tall do you think a beer can is? Give me a
Talking
guess.
tall boys, we're talking.
Just a
small.
regular 12 ounce. Yeah, let's just do a 12 ounce beer. Your standard Bud. How tall do you think it is? Make a guess.
5 inches.
5 inches? I would guess that too. Okay. What if we wanted to work in centimeters instead, like the rest of the world? You don't want to do that?
No clue.
No? Oh,
Just make
fine.
them all the same. Just don't make.
We're the only country, I think we're the only country in the world now that, there were a few other holdouts a few years ago, but we lost them. We're the only country in the world that's not using the
That's what
metric
makes us
system.
the best. Oh, I don't know.
I don't know.
Makes us unique.
It makes us unique. Yeah. Okay, radius or diameter of that can, what do you think? 2 inches, 3 inches, probably somewhere in between there. Let's go 2.5 inches. All right, calculate a volume for me.
2.5, that's the radius.
That would be the
That would be-
diameter, sorry.
okay.
I wrote diameter. I could
5 inch one.
I could think of diameter easier. All right, so that's the diameter, and this is the height. Find out what the volume of this can is. Give it a shot.
So the radius is half.
Radius would be half of that, correct? Yep. What about your calculator? See if you can come up with a number. See if we can agree on it.
I think that the diameter would be even smaller.
You think it'd be smaller?
Yeah.
Yeah, because that's half
Should
of
be 2.
that's half of 5.
So my glass of water here has just over 3-inch diameter, and I think a beer can is just a little narrower. So I think 2.5 is pretty reasonable. So your homework tonight is to go find a beer can and measure it, unless you're underage, and get a soda can. Come on, calculators. Go get a calculator. Let's go. Everyone else get calculators. Get a calculator. Emily, you get a calculator? You got a computer there right in front of you. Use that. Right, you just go right to Google, type stuff in. All right, so you're tired, come on. Hey Stan, this is interesting. The Google calculator stopped working in Chrome. And I think I have the latest version of Chrome, but I'm not sure. I haven't had a chance to troubleshoot it. So like I push buttons and nothing happens.
Where's that formula go again?
Yeah, so I gotta figure that out. You didn't write it down?
No.
What?
You didn't give us our sheet yet.
I know. Oh yeah, I'll go look for that. Oh, you guys calculate that. Good point. Can I borrow your key, Stan, and lock myself out?
No problem. Here.
Is that on this one? I have a pair of shoes just like that, Colt. I call them my fancy dress shoes.
Really?
When I have to put on a suit, that's what I wear. Oh, your key back. Okay, let's see what I get. Half of 2.5, that's like 1 1/4. 1.25, thank you. So pi times 5 times 5. Google says it should be about 25 cubic inches, roughly, depending on which version of pi you use. So double check what you got. I'm going to do the calculation again on a new screen. So let's see. 3.14 times 1.25 raised to the second power times 5, and I get almost the same number, 24.5. And that would be cubic inches. Yeah, so remember, we got to square that radius. So what I entered into my calculator was 3.14 times 1.25 raised to the second power times 5. And that was inches squared times inches is going to give me inches cubed, or cubic inches. Okay, so I just wanted to warm us up with a little work with formulas because we're going to have to do some formula work. So I just handed out 3.2 in the room here. Let me bring it up online. And this is going to take us a couple more days to get through, probably.
Hey, on 3.1, 3.1, when you do the graphs on the questions, is that 3.1?
Yeah.
The charts, the
Yeah.
tables?
Yeah, when you go in there and you do the quadratic or whatever you put on the thing, on the graph.
Oh, yeah.
Okay, that thing, like, it gives you like one chance to do it, and that one to lock up the problem, and then you gotta do another one for some reason online. I don't know why.
Oh, the settings?
Anybody else do
Okay, this was the 3.1 homework?
I think so, yeah.
Okay, let me look it
A
up.
lot of times if I get those ones wrong,
Homework. So it looked like it only gave you one try and then you had to redo it?
Yeah, it doesn't
Okay.
let you mess around with the graph at all.
All right. I'll check out the
You don't
settings
graph
on
it the
that.
first time, and it wants to, then you have to go to a different question or something.
Okay, I'll double check that. All right, so big ideas here I mentioned earlier. We got to be able to play with percentages, which we played a bunch with last term, and then we have to be able to play with formulas. And we're going to pick apart this formula right here and use it in a spreadsheet. So I'm going to break that formula down in just a second. Before I do that, what I want to go is just what blood alcohol content means. So there's a term, abbreviated BAC, stands for blood alcohol content. And does anybody know what the legal limit for a normal driver in Oregon is right now? It's what?
Is it 0.8?
It's 0.08.
0.08.
Okay, so 0.08 legal limit. You can even be in trouble at 0.08. So if you got pulled over and they suspected you of having alcohol recently, and you said, yes, I did, or no, I didn't, they could say, well, we're going to do a blow test maybe. And if you blow exactly a 0.08, they have two choices then. They could either say, okay, you're at the limit you need to stop driving or chill out for a little while. Or they could give you further sobriety tests and say, even though you blew a .08, we think you're more impaired than that says, and so we're going to cite you for drunk driving. So it's a little sketchy thing. You got to be careful about it. Best is just to be always overcautious. But what does .08 mean? Right, so that's what I want to talk about right now quick. So it really means 0.08% alcohol.
Did you know it's not everybody has that limit? If you have a CDL, the limit's lower.
Right, yeah, so I think that's like .06, if I remember right.
If you're a minor, it's none.
There's no, yeah, minor is like any amount of alcohol and you're doomed. Yeah, you're in deep trouble. Yeah. So 0.08%. So remember, what does percent means? It means divide by 100, right? So that really means 0.00 to divide by 100, 0.08. Now let's think about that as a fraction. This is the tenths, right? What's next? Hundreds? Thousandths? 10,000ths would be next. So that really means 8 over 10,000. Well, 8 what over 10,000 what? Okay, and so that's the tricky part. The 8 is grams of alcohol. Versus 10,000 grams of blood. What the heck's a gram? Anybody remember? Gram is a unit of mass. Mass is different than weight, but it's related. Okay, so for example, let's suppose that I weigh 72 kilograms. On the moon, I still weigh 72 kilograms. Mass has nothing to do with gravity. Pounds, that's weight, not mass, so that changes depending on whether I'm on the moon or whether I'm on Earth. So grams is mass, it's how much stuff is in there. Okay, so it's the amount of alcohol, which is also different than volume. And we'll talk more about that stuff later. That's a little trickier because then we have to talk about density. Okay, so think about a ball of lead. Lead's really dense. A small ball of lead is very heavy. A small ball of gold is very heavy, but the same size ball of water is not going to be as heavy, or the same size ball of wood, because wood's less dense, water's less dense than gold or lead, for example. What's that?
How do you have a ball of water?
I don't know. As soon as I said ball of water, I was like, man, that was a stupid idea. How do you get a ball of water? Right. Okay.
Water balloon.
A water balloon. There we go. A water balloon. Thank you for saving me, Cole. Get that. All right. So that's what percent alcohol means. Okay. And again, we'll play more with that idea later. But that's not a lot of alcohol compared to the blood, but it's enough for people to have physically different presentations in the way they talk, the way they move. It's noticeable. Okay. If I have one beer and you start talking to me, you'll know something's wrong with Parker. Okay. And so one beer, I would probably be like a 0.03. One regular beer. It'd take like 2 or 3 beers in a short time to get me up to a 0.08. So if I go anywhere and I have more than one beer, I'm not driving for at least an hour, maybe more. And so we're going to explore that idea. Depending on, and does it depend on the person?
Doesn't it like depend on your weight?
Yeah, it depends on your weight. So let's pick apart the formula. And we got a few more minutes to do that. So let's zoom in on this sucker a little bit. Scroll bar. Screenshot it. So here is the crazy formula. So the B, that's the blood alcohol content. And I'm not going to elaborate more on that at the moment. That was on the previous page. The T, that's the number of hours since your last drink. Next variable up here, N, capital N, that's the number of standard drinks. We got to explore what a standard drink is. So a standard drink would be like a 12-ounce can of Budweiser, a 6-ounce glass of wine, a shot, like 2 ounces of some kind of hard liquor. But if I went to a pub and I got a pint of some craft beer, it would have higher alcohol than a Budweiser, and a pint is 16 ounces, not 12 ounces. So if I went and had 2 pints, that's more like 3 regular standard drinks. Okay, so we gotta be honest with ourselves anytime we're talking about what a standard drink means. Okay, because it just kind of depends. Is a mixed drink that you get at a bar going to be a standard drink? Probably not. There could be multiple shots of different things in there. It just depends on the drink. Okay, so figuring out what it means to be a standard drink, that's a little bit of work. And I have a link to a website that talks about standard drinks that I'll share in a moment. W, that is your weight in pounds. And G is what's called a gender factor. So there's a female gender factor and there's a male one. And let me refresh my memory on those. For females, the gender factor is 0.55, and for males, it's 0.68. And notice that number is in the denominator. So for men, we divide by a bigger number because their bodies are constructed a little bit different. They process the alcohol a little bit different. Men tend to have a little more muscle mass than women, and all that tends to work with the blood versus how the alcohol is processed. And that's just an experimental thing that people figured out as they tested different men and women with different amounts of alcohol over time, and weights. And so if it's a female, we plug in one. If it's a male, we plug in another. So let's just do a test blood alcohol level on that. So let's grab this formula again. So let's suppose we have a male, which means we're going to use the 0.68. And that male had 2 drinks and that their weight is 150 pounds. And I want to know what they just finished drinking those 2 drinks. So what is time going to be, you think?
30 minutes.
They just finished drinking. Time would be 0 if they just finished drinking. Yeah, so that would be their initial. They just finished that second beer. This is an estimate of what their blood alcohol content is at that time. Okay, and so this is going to be 0. So all I have to do is figure out that fraction. So that would be 2.84 times the 2 drinks divided by, and just to be safe, I'm going to say parentheses around the numerator, parentheses around the denominator, their weight, 150, times their gender factor, 0.68. So let's see if we can all agree on what their initial blood alcohol is after finishing that second beer. So try to whip that out on your calculator, see what you get. And then unfortunately, we are out of time for fun with math today. So look up 0.025. If anyone else agrees. Parentheses I put in there are important. I got 0.055. Is that what you said?
I said 0.025.
0.025. I got 0.055, almost 0.06. Anyone else?
0.0556.
Okay, yeah, so this, I'll bring my screen over here. This is what I calculated right there. So I have the numerator in parentheses, I have the denominator in parentheses, so that 2.84 times 2 divide by parentheses 150 times 0.68 close the parentheses. So I need parentheses both around the numerator and around the denominator multiplication. So that person gets a 0.6. For me, not driving yet. That's close enough to 0.08. I don't worry about it. All right, so we'll play around more with how blood alcohol level changes over time, how it's different for a man or a woman, and the number of drinks and what's a standard drink. We'll look that up too. So please, if you haven't already, do the prep exercise for this. It's just playing with formulas, and then we'll dive more into this actual blood alcohol content stuff. Oh, and if you're done with 3-1, yeah, hand that in, and I'll check out the settings for 3-1. Oh, you're 2-9. Thanks, Colt.